This is a video on inequalities. So let's start with something very, very basic. What does it mean to say that x is greater than negative 2? Well, it means that x could be any number, any real number that is larger than negative 2. Not some specific number larger than negative 2, but any number larger than negative 2. Can it be negative 2? No, because negative 2 is not larger than itself, duh. But it could be anything bigger than negative 2. So if we have a number line, and we mark on there 0, negative 1, negative 2. What numbers could x be? Well, it could be negative 1, it could be 0, it could be 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. But that's not it, because there's all the numbers in between those integers that it could be. And so we represent that by putting an open circle at negative 2, because it can't be negative 2, and going to the right to indicate that it's anything to the right of negative 2 on the number line, which would be anything larger than negative 2, including all the decimals and fractions that are in between those whole numbers. All right, so you should know that already, right? Let's solve these inequalities. Number 1, 5x plus 17 is less than 2. So we solve it like we do an equation, in that our goal is to get x by itself. So we can subtract the 17 from both sides to get 5x is less than negative 15, and then divide both sides by 5 to get that x is less than negative 3. So now we've solved that for x. We will write it as a solution set, which means the set of all x such that x is less than negative 3. So that colon there means such that. It's putting a condition on x. We'll take all the x's, the set, that's what these braces mean, the set of all the x's that meet the condition that x is less than negative 3. We'll graph that on the number line. There's 0, there's negative 3. We'll put an open circle at negative 3 because it's just less than negative 3. It can't be equal to it. And we'll go to the left. Number 2, 5 times 3 minus y is less than or equal to 7 minus y. So let's distribute the 5. 15 minus 5y is less than or equal to 7 minus y. Let's get all the y's on one side, maybe by adding the y that's on the right-hand side to both sides. 15 minus 4y less than or equal to 7. Subtract 15 from both sides, negative 4y is less than or equal to negative 8. Divide both sides by negative 4. And anytime we multiply or divide by a negative number, what do we have to do? Switch the sign. Oh yeah, we have to switch the sign. So greater than or equal to positive 2. Negative 8 divided by negative 4 is positive 2. So anytime you multiply or divide both sides of an inequality by a negative number, you have to switch the sign. So here's 0, here's 2. You will put a closed circle, a closed dot at 2, because we'll allow y to be equal to 2. That's what it means for y to be greater than or equal to 2. It can be equal to 2, or it can be anything to the right of 2. A solution set would be the set of all y such that y is greater than or equal to 2. Number 3, 4x is greater than 2 times 3 plus 2x. Let's distribute the 2. 4x is greater than 6 plus 4x. Let's get all the x's on one side by subtracting that 4x that's on the right-hand side to get it over to the left-hand side. While 4x minus 4x is 0x. Is greater than 6. What's 0x? Well, 0 times x is just 0. 0 is greater than 6. What do I do with that? First of all, it doesn't make any sense. 0 is not bigger than 6, right? Well, that means there is no solution. There's no number that we could have plugged in for x at the very beginning that would have made that inequality true. So if all the variables are eliminated and you end up with something that's a false statement, 0 is not greater than 6, so this is a false statement, then you write no solution. What would the graph of that look like? Be an empty number line. I put a 0 on there just to indicate that it's a number line, but I'm not putting a dot at 0. I'm not indicating that could be 0. It's nothing. Number 4, 2t is less than negative 1/2 times negative 6 minus 4t. All right, distribute the negative 1/2. 2t is less than or equal to negative 1/2 times negative 6 is positive 3, and negative 1/2 times negative 4t is positive 2t. Let's get all the t's on one side, subtract 2t from both sides. Oh my god, 0 is less than or equal to 3. No solution? No, because this is true. 0 is, in fact, less than or equal to 3. It's not equal to 3, but it is less than 3, so it meets the condition of that inequality. Interesting. That means that I ended up with a true statement when all the variables were eliminated. So it doesn't matter what number I had plugged in for x, it would have worked. So the solution set is the set of all real numbers. Any number would make that inequality true. What does the graph of that look like? Well, it can be anything. We'll shade the whole number line. A bus is being chartered for the sophomore class trip. The basic fee is $95 per person. If more than 20 people go, everyone's fare is reduced by $3 per person over this number. At least how many people must go to make the fare less than $75 per person? First step in solving a word problem is to define our variable. We want to know at least how many people must go, so let's say let P equal the number of people. Okay? Let's organize our information. We'll do so in the form of an equation, or an inequality, sorry, an inequality. It costs $95 per person, but if more than 20 people go, you reduce the fare by $3 per person for every person over 20. So if 21 people go, it's going to cost 95 minus 3, which is 92. If 22 people go, it's going to cost 95 minus 6, which is 89. So what you're doing each time is taking the 95 and subtracting off from it 3 times the number of people over 20. So 3 times P, as long as P is greater than 20. That's how much it would cost per person. We want that to be less than 75. And now we solve it for P. So subtracting the 95 from both sides, 3P is less than negative 20, which means P, when we divide both sides by negative 3, is greater than, because we had to switch the sign, 20 over 3. 3 doesn't go into 20 evenly, but this is 6 2/3, right? Well, I can't have 6 2/3 of a person, so I need at least 7 more people in order to get the fare lower than $75. So to answer the question, at least 27 people must go. Very good. Compound inequalities. We have 2 types of compound inequalities. The first are called conjunction inequalities. They are also called AND inequalities, compound AND inequalities, because they literally have the word AND, or they have a setup that implies the word AND. So number 6 says x is greater than negative 2 and x is less than 3. Let's look at what that means. We have negative 2 there, 3 there. If x is greater than negative 2, that means it's to the right of negative 2. If x is less than 3, it means it's to the left of 3. But what this is saying is it needs to be both. The AND implies both of those conditions have to be met. It has to be greater than negative 2 and it has to be less than 3. Well, for what numbers are both of those conditions met? Only the numbers in between negative 2 and 3 meet those conditions. So instead of our arrows going past these numbers, we're going to draw only the solutions that work. So that's anything in between -2 and 3. Another way to write that is to say that x is between -2 and 3 by writing x between -2 and 3 and using less than signs, because it's saying -2 is less than x and x is less than 3. So we merge those two single inequalities into one compound and inequality. So we could start with an inequality that's a 3-part compound inequality like that, and that is automatically then an and inequality. To solve it for x, we want to get x by itself in the middle. So whatever we do to one part, we have to do to all 3 parts of it. So to get x by itself here, let's get rid of that 5 by subtracting 5 from everything. That'll give us -2 is less than 2x, which is less than 10. X is almost by itself, we have that 2, so let's divide out by 2. -1 is less than x, which is less than 5. So our solution set is the set of all x such that -1 is less than x less than 5. And when we graph it, we got -1, it's an open circle because it's just less than, and 5, which is also an open circle, and we go in between. Make sense? Good. Our second type of compound inequality is an OR compound inequality. It means the opposite of what the AND one meant. It means it doesn't have to satisfy both of these conditions, it only has to satisfy one of them or the other one. And it doesn't matter which one it satisfies. So x plus 7 is less than 4, or 7 minus x is less than 1. Let's solve both of those inequalities as if they were their own problem. So subtract 7 from this one, x is less than -3. Subtract 7 from this one, and -x is less than -6. Divide that by -1, and x is greater than 6. So we have that x is less than -3, or x is greater than 6. Here's -3 on the number line. To be less than -3 would be to the left of -3. Here's 6. To be greater than 6 would be to the right of 6. And they go away from each other. But that's okay, because this just means I'll take any x that is less than -3. I'll take any x that is bigger than 6. Either one will work. So we write our solution set as the set of all x such that x is less than -3, or x is greater than 6. So the AND inequalities often go towards each other. The OR inequalities often go away from each other. Number 9, 7 minus 2y is less than or equal to 1, or 10 is less than 4 minus y. So we solve each of them for y. Subtract 7 from this one. -2y is less than or equal to -6. Divide both sides by -2, and y is greater than or equal to 3. Or subtract 4, 6 is less than -y, divide by -1. -6 is greater than y, which means, if we reverse that inequality, y is less than -6. So we have that the set of all y such that y is less than -6, or y is greater than or equal to 3. Here's -6, here's 3. Less than -6 is an open circle at 6 and to the left. Greater than or equal to 3 is a closed circle at 3 and to the right. Absolute value equations and inequalities. What does it mean to take the absolute value of a number? Some people would say it just means make it positive. Well, this is the formal definition of it. The absolute value of x means it's x if x is already positive or x is 0. It's the opposite of x, the negative of x, if x is less than 0. So yes, it means make it positive. So if x is -4, the absolute value of -4 is 4. If x is 6, the absolute value of 6 is 6. If x is 0, the absolute value of 0 is 0. So if the absolute value of x equals 1, what numbers make that true? Well, -1 and +1. Both of them have an absolute value of 1. So x is simply the solution set of -1 and 1. Those two numbers are the only two numbers that make that equation true. How about an inequality? If the absolute value of x is greater than 1, well, 2 has an absolute value greater than 1, 3 does, 2.5 does, 1.5, 1.1. So anything bigger than 1 will have an absolute value greater than 1. But negative 2's absolute value is 2, which is bigger than 1, and negative 3's absolute value is 3, which is bigger than 1. So in fact, anything to the left of negative 1 on the number line would also work. So notice the absolute value of x being greater than 1 led to an or compound inequality, that x is less than negative 1 or x is greater than 1. What if the absolute value of x is less than 1? Well, 0's absolute value is less than 1. 0.5's absolute value is less than 1. Negative 0.5's absolute value is less than 1. So we end up with any numbers that are between negative 1 and 1. Anytime x is wedged between two numbers, that's a compound and inequality, where we say negative 1 is less than x, which is less than 1. So notice greater than led to an or, less than gave us an and. That's what we're going to use to solve absolute value inequalities. But first, a couple absolute value equations. When we had the absolute value of x equals 1, we had two answers, when x was equal to 1 and when x was equal to negative 1. So if the absolute value of 3x minus 2 equals 8, we're going to have two answers, one for which 3x minus 2 equals 8, and one for which 3x minus 2 is equal to negative 8. Because if 3x minus 2 equals negative 8, its absolute value will be 8, and it will work. So we'll solve each of those equations separately. 3x equals 10, x equals 10 over 3. Or 3x equals negative 6, and x equals negative 2. We just have those two numbers in our solution set, negative 2 and 10/3. The absolute value of 2y plus 3 plus 7 equals 12. Let's move that 7 over first. We have to get that absolute value by itself. We have to isolate it first. So the absolute value of 2y plus 3 equals 5 when we subtract 7 from both sides. Then we break that up. 2y plus 3 equals 5, or 2y plus 3 equals negative 5. That means 2y equals 2 and y equals 1, or 2y equals negative 8 and y equals negative 4. So we have a solution set for y, negative 4 and 1. And I like to write them in numerical order, but it would be okay if you put 1 comma negative 4. Okay, now an inequality. The absolute value of 3 minus 2t is less than 5. Remember, absolute value less than gave us an and. So here's how we do that. We take the 5, we make it negative and put it on the left side. We stick the stuff inside the absolute value in the middle, and we put the positive 5 on the right. And we get t by itself in the middle by subtracting 3 from everything. Negative 8 is less than negative 2t, which is less than 2. We divide everything by negative 2. So 4 is greater than t, which is greater than negative 1. We divided by a negative number, so we had to switch both signs. So let's flip that whole inequality around, because we like it to be the other direction. Negative 1 is less than t, which is less than 4. So t is wedged between negative 1 and 4. Here's negative 1, here's 4. Open circles at both. Go in between. So the set of all t such that negative 1 is less than t, less than 4. 13. The absolute value of 4x plus 6 is less than negative 2. Wait. The absolute value of 4x plus 6 is less than negative 2. Wait. That absolute value could only be greater than or equal to 0. There's no number I could plug in for x that would make this thing, the absolute value of it, less than negative 2. That, my friends, is a no solution. It will never be less than negative 2. So I just have an empty number line. 14. Absolute value of 2w minus 5 is greater than or equal to 7. All right, remember an absolute value greater than gave us an or inequality. So we break it up into two separate inequalities. 2w minus 5 is greater than or equal to 7. So exactly the way it looks without the absolute values. Or 2w minus 5 is less than or equal to negative 7. So switch the sign and make the number on the right negative. Solve both of them for w. 2w is greater than or equal to 12. W is greater than or equal to 6. Or 2w is less than or equal to negative 2. And w is less than or equal to negative 1. So our solution set is a set of all w such that w is less than or equal to negative 1, or w is greater than or equal to 6. Here's negative 1. Closed circle to the left. Here's 6. Closed circle to the right. Very good. 15. The absolute value of 2r minus 1 plus 3 is greater than 8. Let's get that absolute value by itself. The absolute value of 2r minus 1 is greater than 5. Break it up. 2r minus 1 is greater than 5, or 2r minus 1 is less than negative 5. Solve them both. 2r is greater than 6, r is greater than 3, or 2r is less than negative 4, r is less than negative 2. So the set of all r such that r is less than negative 2, or r is greater than 3. Here's negative 2, here's 3. Open circle at both. To the left of negative 2, to the right of 3, in order to be less than negative 2 and greater than 3. Very good, very good. Here are your immediate practice problems. Solve and write your answers as solution sets of just basic inequality, no absolute values, and then an absolute value equation, and then an absolute value less than, and then an absolute value greater than. So one of each. That's the end of the video on inequalities.